Okay, fifth graders, it's been a while since we've done math, but we're going to pick up right where we left off. And once we get started, you'll be like, oh yeah, I remember we did that. Okay? Today's Monday, January 6th, 2020, and our first math lesson of the new year is going to be Eureka Math Module 3, Lesson 5. Okay? This week we're going to do lessons 5, 6, and 7. And then actually on Friday, instead of having a weekly check-in, you're going to have your mid-Module 3 test. We're already halfway through Module 3 almost. Okay, so you might want to go back and review what we learned before science camp, not even before the break, before science camp about making equivalent fractions and adding fractions. Okay? Today what we're doing is we have already learned how to add fractions, and so today we're going to learn how to subtract fractions. And again, they're going to have unlike units. What that means is we're going to be working with thirds and halves, or fourths and sevenths, things with fractions that have different denominators, because the denominator, as you know, tells you how big the unit is, or what kind of units we're working on. Okay? But first, let's talk about the problem of the You don't need to write this part down, okay? But I'm going to say some sentences to you, and I want you to tell me the answer. If I have 3 boys and I take away one of the boys, what do I have left?
2 boys.
Okay, if I have 3 boys but I take away 1 girl, how much do I have left?
3 boys and 3 boys.
Wait,
2 kids.
where did I take away the 1 girl? Did I have any girls to begin with? No. So can we solve this question? No. Okay, I'm going to circle the ones we can't solve. If I have 3 10s but I take away 1 10, what do I have left?
2 10s.
2 10s. We could do that one, right? If I have 3 fourths and I take away 1 fourth, what do I have?
2
Oh, we could do that. If I have 3 fourths but I take away 1 third, we can't do that. We can't do that. If I have wait, do I end up with 3 fourths and 1 third? No, I'm taking away 1 third from the 3 fourths. So I can't do that. That one says 1 over 2 minus 1 over 3. How do I say that math sentence in word form? Think to yourself. When you know, give me a thumbs up. There's numbers there. In fact, they're fractions. But we can say it using words. We can say 1/2 minus 1 third, right? Or take away 1 third from 1/2. Can we do that?
Yeah, I know.
No. What do all the math sentences have in common that are circled? We can't solve them. Why can we not solve them as they are? Well, because they have different units. You'll notice that first the units was boys, then it's girls, right? Or the unit was fourths, then it's thirds. What is the unit down here? Halves, and then thirds. So whenever we have unlike units, we cannot solve it right away. We have to first change the problem or rewrite the problem in a different version so that we have like units. For those of you who are familiar with Pokemon, I think of equivalent fractions like the Pokemon Ditto. Do you guys know about the Pokemon Ditto?
Yeah.
The Pokemon Ditto has a special power. It can change to make itself look like any other Pokemon. Okay? But it doesn't change who he is on the inside, it just changes how he looks. So with any fraction, we can change. We can write an equivalent fraction. We can write a different version of the fraction without changing its value, just like Ditto. Okay? Let's take a look at that problem then. 1/2 minus 1 third. Go ahead and write that down. Just like when we were adding fractions, we have to rewrite the equation, write a different version of the equation so that we have like units. So by drawing a rectangular fraction model, I can show that before I had 1/2 and I had 1 third, right? But when I overlapped them, I found that 1/2 is equivalent to how many sixths? How many sixths? 3 sixths. And 1 third is equivalent to how many sixths? 2 sixths. So we can rewrite this problem. Instead of writing 1/2, we could write 3 sixths. And instead of 1 third, we can take away 2 sixths. Did I change the value of the problem at all? No. And now I know that when I'm subtracting things, I'm taking things away. So I'm starting with 3 sixths. Here's 1, 2, 3 sixths. Do you guys agree? But I need to take away 2, right? 1, 2. So I'm going to take away this sixth and this sixth. And what do I have left? 1 sixth. So the answer is 1 sixth. We can also use what we know about number sense. If I have 3 sixths, but I take away 2 of them, I only have 1 of them left. And what do I have? I have sixths. So 1/2 minus 1 third is equal to 1 sixth. So here again, we can see that we have different kinds of units. So we have to rewrite them using equivalent fractions. So let's draw some fractional rectangular models to show us. Rectangular fraction models. So there's one for our first term, And there's another one for our second term. Remember that whenever you draw these rectangular fraction models, you have to show that the whole rectangle is equal to 1. If you don't, and it's not equal to 1, it would change everything. Okay, let's first show that we have 1/3. So to do that, I have to make thirds, and I have to shade in one of them, right? And then I have to label it as 1/3. Then my second term is a fourth, and I'm going to go the other way so that I can overlap them better. First I make fourths, then I shade in one of them. Okay, and then I'm going to label it to show that this is 1/4. Okay, when I overlap them, that means I divide this into fourths as well, and I divide this into thirds as well, yes? Okay, so based on our equivalent fraction models now, I can see that 1/3 is equivalent to 4 twelfths, good. And I can see that 1/4 is equivalent to
3 12.
Okay. So now, our next step, there is an extra step because we're subtracting, okay? But our next step is still the same. I want us to get into the habit of always rewriting the problem using the equivalent fractions. So instead of 1/3, we're now going to write